Good morning. Today I will introduce myself. My name is Nur Ayasni. What is assembly language? Assembly language is a low-level programming language. It uses simple introduction to communicate directly with the CPU. For example, move. Instruction tell the CPU to move data from one place to another. Why is assembly language is important? What assembly language is important because assembly language is because give direct control over the hardware. It can improve performance, use fewer resources, and help us to understand how the CPU works. Is also useful for embedded system. The relationship between AL and CA closely assembly language is closely related to computer architecture. It works with CPU memory and input and output operation. Simply, assembly language is converted into machine instruction, which are processed by the CPU and hardware.
Good morning, my name is Loshni Vasu and I'm from DIT1I. So, I'm gonna explain about question 2. First, for the question 2, we are given three inputs which is A, B, and C. Is stored in A is stored in D1, B is stored in D2, and C is stored in D3. The purpose of the question is to use EZ68K assembly language to reproduce the logic circuit and find the final output X. The circuit has not gate and or gate for the upper part and not gate and X or gate for the lower part. And finally an AND gate to combine both results. To the coding, I first load the three given values into D1, D2 and D3. Then I use D5 as a temporary register for the upper part. I copy A from D1 to D5. Perform not on D5 and then perform OR with B in D2. For the lower part, I use D6 as a temporary register. I copy C from D3 to D6. Perform not on D6 and then perform X or with B in D2. After getting the two intermediate result, I use the AND instruction to combine them. Finally, I move the result into D4 because the question requires the final output X to be stored in D4. The coding follows the same order as the logic circuit. Inputs value first, then NOT or and XOR operations, followed by the final AND operation. Thank you.
Assalamualaikum and good evening. My name is Farah Fahana Belita Arifin. Today I want to present about this slide about answer of question 1. This slide shows the process of executing the assembly language instructions. The table shows the value of each register before the instruction, the steps taken during the process, and the value after the instruction. We can see how instructions such as move, add, sub, and not change the data stored in the registers. This helps us understand how the program works step by step. First, the binary value 1001110 D1 is moved into register D1. The value is converted to hexadecimal which is 9E. So D1 become 00009E. So next, the value stored at the memory address 472 is added to D1. The value 4372 in decimal is 08FA. So 009E plus 08FA equals 0998, and D1 becomes the 00000998. For the third instruction, this instruction moves the value from data register D1 to address register A1. Therefore, A1 receives the value. The value for A1 is 00000998. For the fourth instruction, here the decimal value 9105 is moved into D2. Therefore, D2 becomes 00002391. This is for the fifth instruction. This instruction subtracts the value in D2 from D1. So 0998 minus 2391 equal FC07 in hexadecimal using Stowe's complement representation. Therefore, D1 becomes 0000 FC07. For sixth instruction, the value from D2 is copied into address register A2. So A2 becomes 00002391 as shown in the slide. For the seventh instruction, next the long word hexadecimal value DE6812 is moved into D3. Since it is a long word operation, D3 stores the full value 00DE6812. For add instruction, this instruction copies the value in D3 into address A3. Therefore, A3 becomes 00DE6812. The ninth instruction is the AND operation. The AND operation is performed between D1 and D3. The hexadecimal values FC07 and 6812 are compared bit by bit. The result is 6802. So D1 becomes 00006802. Lastly, the NOT operation is performed. The NOT operation is performed on the lower byte of D2. The value 91 is inverted bit by bit, resulting in 9E. Therefore, the lower byte changes to 6E, giving D2 as 0000239E.
Hi, Assalamualaikum. My name is Nur Aina binti Marizan. First, we have hash 6754, which represent an outer value. After conversion, the value is 6754 and it is stored in D1. Next, we use move word hash binary, 10101111 to D2, which give us 00AF in hexadecimal. Then A3F9 is moved to D3. So D3 contains A3F9. After that, we move D1 to D5 and perform northward D5, changing the value to F213. Then we perform outward D2 with D5, giving F2BF, so D5 become F2BF. Next, we move D3 to D6. After northward D6, the value becomes 5C06, and after recursive word outward D2 with D6, we get 5CA9. Finally, we perform N-word D6 with D5, resulting in in 50A9. We then move D5 to D4. Therefore, the final answer is D4, resulting 000050A9. That's all. Thank you.